one nice thing about knowing the dimension of a space is it gives you some idea of how big a collection of linearly independent vectors can be. So if we have a vector space of dimension n, how big could a linearly independent collection of vectors be? Well, let's suppose that we have a collection of vectors, say, of size n plus 1, and let's take a basis b, let's say beta 1 through, since it's a basis in a space of dimension n, we know there has to be exactly n vectors. Okay, well, so our question is, could these possibly be linearly independent? Well, what we're going to do is just one by one do the exchange theorem. So let's suppose that these are linearly independent. Okay, so we can one by one replace the betas with v's by doing the exchange theorem, and what we'll do is transform this basis with betas into a basis with v's, right? And the exchange theorem will tell us that this is a basis for v. Well, look, if this is a basis for v, then v sub n plus 1 is in the span of v1 through vn. And if v sub n plus 1 is in the span of the rest of them, that means v sub n plus 1 is linearly dependent on these v's. And that means that v1 through v sub n plus 1 is linearly dependent. Right? So that contradicts what we assumed. So our assumption must have been false, right? If we have more vectors than dimensions, they have to be linearly dependent.